Let us see them. So, thus it is impossible to use conventional engineered construction material in building. You have to use them. You cannot avoid, you can't build a large hospital with all bamboo, mud or whatever is naturally available without much processing them. You have to do some processing. So, it is only prudent therefore, that we use our engineered materials very judiciously and optimally. From thermal design point of view, so reduction of wasteful misuse of material, this is very, very important in the context of green building or green construction and sustainable construction. So, energy used in production, transportation of materials is called embodied energy, right. So, embodied energy of the envelope material is very, very important. Obviously, carbon dioxide is another issue, right. You know that OP cement, ordinary Portland cement, it produces a large quantity of carbon dioxide next to only fossil fuel, but I do not think I will go into that aspect. The point is important, carbon dioxide emission and embodied energy is important. If you see embodied energy, this result is from Trucker's publication. Trucker is the author. You will find that aluminum sheet has got a high embodied energy per ton, gigajoules per ton. Concrete has got pretty small amount, and if you see glass, somewhere glass will be there, float glass is talking about, and various other, they have got high per ton. But the thing is that when you look at building, typical building, this is from Tucker's 2000 data, but if you look at it for a typical building, you find this is the major component, and if I look at glass, it is somewhere there, steel is there. So, why? Because the quantum of concrete used in buildings typically, in general over the world, all over the world in terms of gigajoules, in a typical building in general, many buildings, large quantity of concrete, while the other materials used are less, although per ton embodied energy is more. Anyway, this is one issue. So, you have to see that embodied energy of the envelope material, if you are talking of envelope or whatever you are using, is relatively low. But then we would be talking about something called operational energy, right, and that operational energy is consists of yearly heating, ventilation and air conditioning load, cooling load, heating load, cooling load and all those kind of things. So, if you look at this, this is called operational energy, and over the life cycle of the building, if you look at it, let us say 60 years of life cycle of the building, right. So, in time in years, so initially is the embodied energy, which is only a small component. Then there is some gray energy which might be related to maintenance and thing over the years, but operational energy cumulative values, it goes on increasing, because every year you are using this operational energy, that is your energy cooling and heating load of the yearly heating and cooling load. So, that is very high, that cumulates. This largely this quantity is relatively not more than 10-15%, even less 7% or so, depending upon type of building. So, operational energy is very, very large, something you might recover even later on, because after demolition, after finishing intended design life or service life of the building itself, life during time period during which the buildings are usually typically in service, you can talk in terms of intended life. So, you can see that some amount is recovered also. So, operational energy is a major part, because that is yearly, every year that is recurring, while in embodied energy is only the initial part of it. So, that is what it is. So, operating energy is a major contributor, and therefore, depends upon environmental temperature, relative humidity, solar radiation, that already we have discussed, and impact of climate change would have, of course, if that is there, which is a lot of people are apprehensive of the climate change, and if the temperature increases, it will be actually having a cascading effect of building energy use. So, minimization of this impact would require better control of envelope and equipment through better greener materials and technology and so on. So, therefore, that is now the property of the envelope, opaque material, solid material, as well as solid opaque material or transparent material, let us say even glass. One of the properties of the glass is also, because glass other properties are important, we call it U value. I will not define the mathematics behind it or algebra behind it or equations of heat transfer and all, that would be difficult to define in this short period of time. Now, this is related to thermal conductivity of the material. It is a property of the material which is nothing but the quantum of heat that would transfer, would take the heat transfer quantum of heat that will be transferred in a solid material under steady unit temperature gradient for unit area in unit time. So, its unit is thermal conductivity is that, and for a construction we call it transmittance, and it is given a name of U value because symbol is used is U. If you remember, even in electrical engineering we talk in terms of resistivity and resistance, conductivity and conductance. So, conductance is of an element, conductivity is the property of the material, and when we take an element complete with some air layer on both the sides, we call it transmittance, and that is what we define as U value. So, it is the important material property in mechanically conditioned building, in mechanically conditioned building. In natural building conditioned building, thermal capacity is also important. There is something called time lag and amplitude decrement. Now, let me just quickly explain this, although again the detail would not be will be available, will not be available in this course, this lecture. If you have a thick wall, it will first store the heat. If there is a temperature change outside, if the increase in temperature occurs outside, right, it will first store the heat. The wall or the roof, solid material or element of the building, external element of the building, it will first get heated up itself. So, it will store the heat. Getting heated up means sensible heat storage. So, it will store that heat, and then subsequently after getting heated up itself, it will radiate that heat. Conduction would occur and comes to the internal surface, then it transmits that heat by convection and radiation to the internal space or inside the space within the building. So, it takes some time, there is a time difference because it can store, and storage element holds the energy and then releases it. So, there is a time gap between its receiving the heat and transmitting to the outside, and when you deal with mathematically for a periodic wave, you can define something like time lag, phase lag, etc., etc. And if it is periodic heat flow, then it has got an amplitude, and there is something called decrement in amplitude. So, this is one aspect is important, the amount of heat that is conducted. This is related to the amount of heat that is stored, because thermal capacity is there, and amount of heat that can be stored and released later, that governs this part of it. So, in conditioned building, it should not allow heat to come in straight away. So, conduction part of it, that is very important, but in naturally conditioned building you can tinker around with the envelope to control the heat coming in. We will have some example coming in, time of heat that that time of heat intrusion or heat entry into the inside of the room, right. Another thing is very important, long wave emissivity of surface is important, short wave emissivity of the surface, external surface is important. We will discuss about this somewhat later on, because the solar radiation is absorbed by the surface. Now, amount of radiation will absorb depends upon a property called, or rather is quantified through a property called absorptivity, and it can emit back in the night because external cosmos or sky is cool. So, the terrestrial bodies actually radiates heat back to the outer space, and that is long wave radiation. Well, why long wave radiation? Because earth radiates at much lower temperature, and the characteristics of that radiation is high wavelength, right, while the one that is radiated from the sun, because sun radiates at very high temperature, it is a high energy radiations, they are short wave radiations, right. So, that is what it is. Okay. So, we have seen actually if somebody calculates out, one would see that insulation, which is nothing but 1 over u, right, 1 over u, u value is transmittance, 1 by transmittance. As it increases, the cooling load actually percentage of energy saving increases, but then does not increase continuously monotonically. There is a point beyond which increase is relatively less. This is from an actual simulation scenario in some building in actual building in Chennai, but assuming that they are in 4 different climates of the country, this is what we did. Okay. So, in case of concrete or similar material, thermal conductivity or brick, thermal conductivity largely depends on porosity of the material, and conductivity you can model them in terms of conductivity of solid and pores. I do not think I will go too much into it, and equivalent solid conductivity you can find out, it depends upon mineralogical composition of the aggregate, etc., and one can estimate. Concrete is of course the roof usually, or various even modern industrialized construction, you might have a wall made up of concrete or precast elements of concrete which are being used. So, brick concrete is significantly used, and its conductivity properties are important, that is what we are talking. So, thermal conductivity or similar material varies with porosity. Higher the porosity, conductivity is less, right, as you can see in dry state as well as in saturated state. So, when moisture actually conducts 6 times, 25 times more than that of air. So, a saturated material transmits more heat than dry material, and that is what you can see, this in saturated condition, this in saturated condition. So, typically in dry construction material, it is a function of porosity, it is a function of porosity, and as porosity increases, conductivity reduces, right. So, if you want an insulation material of this kind, granular material bonded together or sintered or vitrified material, if they have low porosity, they will have lower conductivity as well. Higher porosity is higher porosity, they will have lower conductivity. So, porosity, high porosity, low conductivity, low porosity, high conductivity. Obviously, there are other properties one has to look into. So, insulation material usually porous, many of them are, and of course, there are varieties of other materials that could be there. So, this is one issue that I wanted to talk about, U value for external roof, wall, etc., that is important. Typically, if you look at it, external temperature variation, for example, this is a case of Delhi measurement, outside temperature, real measurement in IIT Delhi campus somewhere in 1980s, month of May and month of August. Now, you can see that, you can assume that the temperature repeats itself after 24 hours, and mathematically we call it periodic. So, when a function, when a function or a variable, or when a quantity or something, for example, here temperature, which varies or which becomes same after certain period of time, here 24 hours period of time. For example, a function of the temperature function of x plus let me call it theta is equals to fx, then it is periodic. Theta is what is called time period, right. So, in our case it is temperature at temperature at any time t, say 8 am or something, plus 24 is equals to t into t. So, today 8 am and tomorrow 8 am, it would be similar. There are some variations, not exact, but usually it is periodic. So, one can assume it to be periodic, and these are typical measurements, and it will have some sort of a mean. It can be described by a mean and a amplitude, as we call it, or variation above the mean. So, if you look at it, this is the external temperature, this is the external temperature, right. This is the external temperature which is periodic, its mean is here, right, its mean is here. Internal temperature will have this peak shifted by some time, depending upon the thickness of the wall or its heaviness, I will say, not thickness alone, thickness plus density, specific heat and all that, depending upon that. So, heavy wall, plus there is a reduction in the swing, this value, this amplitude reduction will be there, right, and this is what we call as time lag. This is what we call it time lag. The swing has reduced this peak has, its value is now somewhat lower, amplitude is somewhat lower, and the shift inside temperature, this is inside temperature, these are external temperature, these are internal temperature, there is a shift in the peak of the internal temperature, and its amplitude is also less compared to its compared to mean. So, light wall, this is a case of light wall, this is a case of a heavy wall. So, in case of a heavy wall, time lag and swing depends on thermal capacity, density into specific heat amount. L into length into density into specific heat, that is precisely wood control. So, therefore, we can choose the wall element or roof element in such a manner that I might like, some cases I might like to do that. I will just give you an example. I like to keep this high. Some cases I may not like to keep that height. I mean, it is not necessary to keep it high, right. I might like to keep them high, and in that case, or appropriate, I will say. So, I can choose the envelope accordingly. So, effect of this is one aspect, we will look into it. Second thing is radiation falls onto opaque surface. For example, over the roof element, external element or many other external element, direct solar radiation, sun's radiation will fall onto them, and we must be able to take them into account in some manner. One of the simplest way of doing it through an equivalent temperature. Through an equivalent temperature, we call it soil air temperature. So, this is dependent on what is called short wave absorptivity, and long wave emissivity also somewhat contributes to it, not very significantly, relatively less, because amount of long wave radiation is usually much less compared to the amount of sun's radiation that is received on any external surface. Okay. What we know is from all mathematical descriptions and quantification of that, sequence of layer does not influence the steady flow or U value as I mentioned, but it has got an effect when you have an alternating flow, because first it will store then release. So, if you put a heavy material in the beginning, it will store for longer period of time, but if you put a light material at the external facet, it will absorb, store it for less period of time, then transmit. So, this sequence of material, whether outside material is heavy, lot of mass, lot of thermal mass I am talking of, that is the specific heat and density, heat capacity, or less heat capacity, that will dictate. But while conduction part of it is independent of sequence of material. So, this is some aspects. Now, we will look into some aspects, then some more we will look into when it comes. Now, in thermal design of building or energy efficient building design of building, the decision variables are envelope parameters which I have discussed so far. Orientation is the other one, shape, type of glass and the fenestration location, shading devices I will discuss some of them. These are the decision variables, and you want to find out the best combination, you can use some sort of optimization process. For example, evolutionary algorithm of the kind of genetic algorithm, etc. But then you must have a method for estimating the quantum of heat coming in. One such method is what we call admittance method. I am not obviously going to go into the mathematics of it. There are other methods like there are numerical methods one can use for calculating the heat transfer, finite element, finite difference, and there are some other kind of solutions. Many software might be using them, like time domain solution of heat transfer equation for a periodic wave outside, so etc. etc. So, this there are methods, so one can use them.